Hello everyone, my name is Benjamin Lee, and I'm a postdoctoral researcher at the University of Stuttgart. I am presenting our work on design patterns for situated visualization on behalf of my co-authors Michael Sedlmair and Dieter Schmalstieg. There is now considerable research interest in situated visualization and analytics by the visualization community. Prototypes such as Corsican Twin, RagRug, and Pearl clearly demonstrate how data can be shown in situ using augmented reality. Very recent surveys have aimed to summarize the technologies, contexts, and applications which situated visualization and analytics have seen use in. These works examine situated visualization from a high-level perspective and do not strictly focus on the design of situated visualizations in the context of their physical reference. On the other hand, the AR research community has been researching how to design visualizations around physical objects and environments for decades. We believe that such designs are still considered situated visualization, even if they do not use VIS idioms. Therefore, there is potentially much to be learned by looking at this AR literature. On closer inspection, it is apparent that there are recurring patterns in the design of situated visualization, even though they may serve different purposes. For instance, all of these works use trajectories, but the two above use it to show some sort of path to be navigated along, and the two below use it to link reference and/or visualizations together. This led us to the question, what are the common design patterns used in situated visualization with augmented reality? In the same way that we use idioms to describe distinct designs in InfoVis, what is the equivalent for situated visualization? To this end, we proposed 10 design patterns of situated visualization. These were identified and grounded through a survey of 293 papers in both the AR and visualization communities. These patterns provide a baseline vocabulary for situated visualization and can serve as starting points for future designs. Let's go through each of these patterns one by one. Glyphs are graphical marks at one or more discrete parts of the referent. Their exact spatial position carries significance, depending on the use case. An obvious example is to show data values at specific parts of the referent, such as in sight lens by White and Feiner. The very classical AR use case of glyphs is to guide the user's attention, whether it be to locate a particular object or to show navigational waymarks. Alternatively, glyphs can provide further visual cues as instructions to perform some physical task, such as to indicate how an object needs to be aligned for insertion, or to show which switches to push, flick, rotate, etc. In contrast to glyphs, decals position information along a continuous region of the reference surface. The most recognizable form of this is in the form of heat map, such as to show regions where people stood the most, or crop yields of vineyards. Decals can also simply overlay graphics on physical reference, particularly when they share semantic meaning. For example, instructions may be overlaid onto kitchen appliances, and the AR overlays might show additional information on top of post-it notes during infinity diagramming. Decals can also provide further visual guidance to aid in a physical task. For instance, they can make it easier to identify where to insert a needle on a patient's body, or make it easier to align physical objects along a virtual grid. As mentioned earlier, trajectories draw relationships between entities or points in space. The natural usage of this is to show movement paths, be it for navigation, a physical movement that needs to be performed, or for post-hoc analysis of spatial temporal data. They can also make explicit connections between a referent and its accompanying visualization, such as the amount of pressure in a fuel nozzle. Trajectories can also connect two physical referents together, such as to indicate which terminals to connect a wire between. Ghosts are 3D graphics that resemble actual objects. A familiar use of ghosts is to show where objects or people were at a previous point in time. This may be to review a motion sequence that was just recorded, or to provide more context when analyzing spatio-temporal data. Ghosts can also show where objects can or should be in the future. For example, they can be used to aid in planning factory layouts, or to indicate where some physical object needs to be placed in an assembly task. Labels are perhaps the most straightforward and familiar pattern in the AR realm. The classical use is to indicate to the user what parts of the reference are what, most typically using text. Labels may also be combined with regular visualizations to provide further information about the referent. The content within the label can also respond to changes in the environment that are caused by the user. For instance, labels can show measurements between objects that the user is holding, or show how much an object is being translated or rotated by. Magic lenses commonly serve to reveal the internal 3D structure of reference as a form of X-ray. As such, they are useful when opening said reference is impractical, such as for teaching human anatomy or for infrastructure maintenance. Lenses have also been used to allow people to simply see directly through objects to mitigate against occlusion. A simple example is the interactive objects that are out of view behind another object. A more applied example is to provide visual cues to ensure correct insertion of a screw into a patient's pelvis. Rather than just overlaying graphics onto the referent, morphs directly reshape and modify the structure of the referent entirely. As an example, consider this toy car which has its structure and components expanded out in an explosion diagram. Proxies are a visual replication or digital twin of the referent itself. The obvious use of proxies is when the referent is too large or small to be seen all at once. 3D maps and 3D worlds in miniature generally fall under the definition of proxies. Proxies are generally well suited for interactive exploration, allowing users to understand the reference in question. This can range from browsing products at a store to exploring large and distant buildings that are otherwise difficult to see in person. Virtual mirrors are a form of situated visualization that requires the user to look at a separate 2D plane. They are naturally suited for when the user themselves are the referent, such as to show personalized data visualizations on one's own face, or to follow makeup instructions. Mirrors may also be useful to provide an unobstructed view of the referent to display annotations and guidance on. This is especially during 3D manipulation and assembly tasks, where one's hands may unintentionally obstruct the referent. Lastly, panels are the most generic but also a common form of design pattern. These are typically standalone graphics that stand independently from the referent. Panels can also show many forms of information, be it data visualizations, text, or general use interfaces. It is important to note that these patterns are not mutually exclusive. Miria by Bushel et al. Clearly demonstrates this clearly. It can potentially use all 5 patterns that you see on screen, but each are independent of each other in a multi-view setup. On the other hand, certain designs may be composites of these 10 patterns. As a basic example, a label with a leader line is technically a combination of a label and a trajectory. Overall, our 10 patterns summarize common high-level approaches for situated visualization, which we hope makes it easier to envision, design, and describe future situated visualizations. To further aid in this endeavor, we also contribute in our paper, The Design Space, which formally describes how situated visualizations may vary, and constraints and guidelines which directly influence this design. As always, please see the paper for the full details. Thank you for listening.